Recall that we have classified literal inequalities based on the degrees as linear, quadratic and cubic. Up till now, we have learned to solve and graphically represent the linear inequality in one variable and two variables. Quadratic inequalities too can be solved using the algebraic and graphical methods. Recall that quadratic equation is a second-degree polynomial equated to 0. Now, if the equal to sign is replaced by any of the inequality symbols, then what we get is a quadratic inequality. Let's explore how to find the solution set of quadratic inequalities in one variable, both algebraically and graphically. Consider a quadratic inequality x squared plus 3x plus 2 less than 0. First, convert the quadratic inequality into an equation by replacing the inequality symbol less than with equality sign as shown. Next, solve the quadratic equation by splitting the middle term. The roots of the given equation are x equals to -1 and -2. Now, consider a number line and plot the roots -1 and -2 on it. Note that these two roots divide the number line into three regions as shown. In order to find the solution set out of the three regions, choose a number from each region, say, choose 0 from the first region, -3/2 from the second region, and -3 from the third region. Next, test whether these selected points satisfy the given quadratic inequality or not. If the result is true, then that region is a solution set for the given inequality. Note that the point from the second region satisfies the inequality. As a result, the second region is the solution region of the given quadratic inequality. Hence, the solution set is the open interval -1, -2. Let's summarize the steps to find the algebraic solution of quadratic inequality in one variable. Solve a quadratic inequality x squared plus 3x minus 18 less than 0. First, convert the given quadratic inequality into a quadratic equation x squared plus 3x minus 18 equals to 0. Label this quadratic equation as equation 1. Next, find the roots of the quadratic equation by solving it. Plot the obtained roots 3 and -6 on the number line such that the roots divide the number line into three regions as shown. Now choose a number from each region and test it in the original inequality. If the result is true, that region is a solution to the inequality. Note that point of second region satisfies the inequality. As a result, second region is a solution region of the given quadratic inequality. Hence, the solution set is the open interval -6, 3. Let's see how to solve the quadratic inequalities graphically. To start, let's first consider these quadratic inequalities. First, equate quadratic expression in each of these inequalities to y. Observe that each of these quadratic equations graphically represent a parabola as shown. Also note that where the coefficient of x squared is negative, the parabola is opening downwards, while in case of positive coefficient, it opens upwards. The roots of the equation are the 2 points where the graph of quadratic equation intersects the x-axis as shown in each case. Let's recall the steps to sketch a parabola corresponding to the quadratic equation 2x squared plus 3x minus 2. The first step is to get the ordered pairs that satisfy the quadratic equation. Next step is to plot ordered pairs obtained in first step. At last, join these points and we get a parabola as shown. Observe that the graph intersects the x-axis at 1/2 and -2. Also, the parabola is open upwards as the coefficient of x squared is positive. Observe that the graph divides the x-axis into 3 intervals: x less than -2, x lying between -2 and 1/2, and x is greater than 1/2. Now, as the inequality 2x squared plus 3x minus 2 greater than 0 is of greater than type, so the solution will have the x values for which the graph of the given inequality lies above the x-axis. Hence, identify for which of the 3 intervals the graph corresponding to the given inequality is above the x-axis. Note that the parabola is open upwards, so the region at the ends is above the x-axis. Hence, the solution set of the quadratic inequality 2x squared plus 3x minus 2 greater than 0 is union of open sets minus infinity, minus 2 and 1/2, infinity. Let's summarize steps to solve quadratic inequality graphically. Solve the quadratic inequality x squared minus 6x plus 5 is less than 0. To make the graph of the given inequality, so for convenience, equate the quadratic expression to y as shown. Since the given inequality is less than type, so the solution will consist of the x values for which the graph of the given inequality lies below the x-axis. Now, take y equals to 0 in equation 1 in order to find the x-intercepts where the graph of the inequality will intersect the x-axis. Now sketch a parabola that opens up and has x-intercepts at 1 and 5. Note that the parabola divides the x-axis into 3 intervals as shown. Observe that the graph of the given inequality is below the x-axis for x lying between 1 and 5. Hence, the solution set of the given inequality x squared minus 6x plus 5 less than 0 is an open interval 1, 5.